Okay guys, in this video we are going to start talking about solving equations with radicals. And right now you can see that I'm trying to solve these two equations and they look almost the same, except the plus 2 that you see on the left hand side is not under the root in the first example, but is under the root in the second example. So let's take a look at the difference between the two. And what are we supposed to do to solve equations involving radicals? So your step number one is to find the radical and what we say isolate it. What that means is the radical has to be by itself, either on the left side or on the right side of your equation. Okay? So in the first equation, let's locate the radical. So I have it right here. Okay? It is not by itself because it also has a plus 2 on the left hand side, and that should not be there. So in order to isolate the radical here, you have to do an operation opposite to addition, which is subtraction. So we're going to subtract 2 from both sides. That's going to cancel the 2 on this side. And then on the other side, you get 7 subtract 2, which is 5. So now the radical is isolated, meaning that it's just by itself on the left hand side and there's something else on the right hand side like a number. Okay, so what is our next step? So what you need to understand that in order to dig that x from under the square root, the rule is that you have to perform an operation that is the opposite of square rooting, which is a square. So if you want to undo the square root, you need to square. And that's what you need to do next. So you're going to put a square on each of these two terms. So what is the squaring does, it just gets rid of the square root on the left hand side. So when you're squaring a square root, the square root disappears. And then you're just going to have x on the left hand side, and on the other side you do need to understand that 5 squared will not, that squared is not going to disappear. That is 5 squared, which is 25. So that's my answer, x equals 25. Now, as with any one of these equations, you need to check this equation to see if it works. Generally, it's a great idea to, whenever you're solving any kind of equation, no matter what kind, is to substitute the value you found back into the equation and to see if it works. But it becomes even more important here because sometimes your method of solving is completely correct, and yet when you plug in the number, there's something going to be wrong. And the problem with that is because when you're squaring, negative goes away. And so sometimes you get these solutions what are called extraneous. So they're not really solutions of the original equation. Because the original equation, so just to give you an example, if you, for example, say that negative 2 is equal to positive 2. Well, obviously everybody understands that that's wrong, right? But if you square both sides, so if you take negative 2, and as you can see, I'm putting it in parentheses, right? Negative 2 squared is 4, and 2 squared is also 4, and that is correct. So when you square, something might be there that wasn't there before. Okay, so that's why some of these solutions may be what's called extraneous. So I need to take this 25 and I need to plug it in for x. And when you plug it, you always want to plug it back into the original equation. So in this case, square root of 25, that's a 5 plus 2, so that's 7. That is correct. And that means that 25 was really a solution. Okay, so turning our attention to the second equation, which looks just like the first, except we have a square root of the whole x plus 2 is all under the root. So how do we solve something like this? So remember that the first step is isolate the square root. Have it by itself and move everything else to the other side. Well, there's nothing to move because square root is already by itself. So if that is the case, you need to get rid of that square root. And again, remember that operation that gets rid of the square root is a square. So we're going to square, in this case, both sides. Now, if you have an expression under the square root that has more than one term, As in the first example, you didn't have it. You only had like one term, which was x. But here, there's x plus 2. When you do this sort of stuff, you need to understand that you are going to be taking the square root of and then squaring it of that whole expression, right? So that's going to be left. So that x plus 2 is going to be left, right? So when you square in the square root, that's what happens. Like it kills the square root, basically, the square. On the other side, also, it's important to remember that 7 squared will not get killed, quote unquote. That is still going to be 49, right? 7 squared, that's going to be 49. That's not going to be 7 anymore. Now, to subtract 2 from both sides, I get x equals 47. So I think that maybe that's correct answer, but I still want to do a check. So I'm going to take that 47, okay? And I'm going to take the 47 and plug it in for x in place of x. I'm going to put it there. So I get 47 plus 2. And that is square root of 49. And square root of 49 is 7. So that means that I am done. So I just did the check and it's correct.